Hi, I'm Terry Stewart, Director of Sales Engineering for ShieldX Networks. Today, I'll be presenting a short overview of the ShieldX Elastic Security Platform. ShieldX ESP is a lightweight, software-defined network security application which continually monitors, and if you choose, protects your public or private cloud environments. Unfortunately, the attackers are not abating, quite to the contrary. They are increasing their activity. And phishing-styled attacks are the top techniques used according to the recently released Verizon breach report. And if recent FBI statistics are any indication, 2020 will be much higher in terms of number of breaches reported. This only heightens the need for added visibility, especially with respect to east-west traffic where visibility is at its lowest and where cloud environments lack the native capabilities. Thus, additional tools are needed to fill this gap. With the increase of work-from-home activity, the attack surface has grown at least an order of magnitude higher than previous years. Most likely, it's multiple orders higher. This puts existing staff, processes, and technologies to the test. So let me show you how ShieldX can help. ShieldX has three core value propositions in its platform. The first is visibility. Using native cloud APIs, we provide continuous workload discoveries. So as workloads are provisioned or deprovisioned, we see them. We add to that machine learning of the traffic between those workloads, and not just A to B, but how they function together from an application, thus giving us the ability to put those workloads in an application group. We then leverage native tags, CIDRs, attributes, naming convention to add additional context to that learned traffic. And of course, because all traffic, or most traffic, is encrypted, if you provide us a certificate, we can decrypt that traffic to see inside of those packets. And of course, we don't forget the security operations staff in your environment. We're fully syslog capable and RESTful API compliant. So we support all of your SIM and SOAR folks easily. Second is threat detection. We use three techniques for layer 7 detection and monitoring. The first is deep packet inspection. This is where we discover those network-borne attacks. Next, we use file inspection. Think of it as sandboxing, where we decode the packet, reassemble that content, and detonate it in our cloud. We use static and dynamic code analysis and a little of our own secret sauce to see if there's any threats within that content. Lastly, we use URL classification and IP reputation-based detection to be able to pick up those phishing and ransomware attacks that perform CNC call homes. And of course, because sensitive data may be flying around the environment, we layer on sensitive data inspection. We have 70 different classifications of data that we look for. If you have additional classifications, we can add those into the environment. And of course, for the operation folks, we have multiple mechanisms to do packet capture. Everything from full streaming packets to individual rules by specific direction type of packet capture, and everything in between. And lastly is virtual patching. This is where we can layer on those protection capabilities. And because we have very fine-grained rules, we eliminate false positives in your environment. And these rules perform from layer 3 through layer 7 in a single rule, thus reducing the rule set and reducing complexity of the platform. We support over 2,800 application protocols, and we can protect multiple clouds in a single rule simultaneously. And this is very important for you, for those of you on your cloud journey. So as workloads move from one cloud to another, whether that be public to private, or private to public, or public to public, your policies will move along with them. And when you do decide to go from detection to protection, we do all of the orchestration for you. So if any of you have ever had challenges with segmentation in the past because of its difficulty and all of the work that your staffs have to do, We can do all of that because of our interaction with the cloud native APIs in just a few clicks. So let me show you how it's done. Welcome to the ShieldX browser-based interface. The one you're looking at here is running in VMware, but it could easily run in Azure, AWS, or Google Cloud. Most of our customers do run it in a private cloud environment, and that's usually a resource issue, but no matter where you run it, you can manage your full in-cloud environment. So if you're running it in private, you can manage the public instances. If you're running it in the public cloud, you can manage the public as well as the private instances. What you're looking at here is the dashboard. I generally like to start here because I like to reinforce the fact that we're very security operations aware. So everything that you see here can be funneled off via syslog, but we do have reporting capabilities native within the platform. And these are customizable. The widgets are moved at will. So even while you're looking at them, you can move them around, you can make changes to them, you can remove them, and you can create custom dashboards on the fly. But after you've deployed the interface, which generally takes 30 to 40 minutes in a given environment, the first thing you do is define the cloud environments that we're going to monitor. In my demo environment, you can see I have an AWS instance, 2 Azure instance, and a VMware. And you can have multiple instances. In fact, that's the beauty of it. You simply have to define to us the particulars of a given cloud infrastructure. Once you do that, the add button will be freed up for click, and we'll define that cloud environment to our environments. So if it's a half a dozen Azure, a dozen AWS, and 2 or 3 VMware data centers, we can handle all of that in the environment. And the very first thing it does once the definition is made is it goes out using the native APIs and it enumerates those particular cloud environments. So in this case, you can see my 2 Azure environments, my AWS down here, and off to the right side, my VMware environments. And you can see all the particulars. You see the regions they're running in for the public clouds, their VNets in the public clouds, the subnets within the VNets, or if it's just a data center within VMware, you see the VLANs that are in there. Each dot you see on the map is a workload within its given network structure, and we color code those dots for your at-a-glance capability. The white dots are workloads that we're aware of, but not doing anything with right at this time, no monitoring or protections, and that's by choice. Many of our customers choose not to, insert into every environment. They just simply want to, look at particular workloads. The amber that you see off into the right side are monitored workloads. So we're just looking at the traffic, just inspecting it. If there is an anomaly somewhere, we do alert on that. And that inspection is layer 3 through layer 7. So all of our technologies are applied to that, and any alerts or rule violations that we see will be generated. And if there's a syslog server, we'll be sending those off as well. Off to the bottom here, you'll see some aqua colors. Those are micro-segmented. Those are being protected. So think of it as a little cocoon around each one of those workloads, or possibly group of workloads. We'd have to look at the rules to see what they are. But we're providing layer 3, 4, and layer 7 protections around those. The other thing that we do in the environment, in addition to observing the comings and goings of workloads, is to observe the traffic that we're seeing between the workloads that we've discovered. And not just workload A went to workload B, but that we're actually looking at it from an application interaction. So we layer machine learning on to look at those workloads from their application perspective. And then we group those workloads by an application tier. And you'll see that application tier across the top side of the interface. In addition to observing that interaction, we also look for anomalies in the traffic, and that will be indicated by the vulnerabilities. So if something is happening in that particular traffic scheme, we'll alert you to that to tell you that there is some problems potentially with that traffic. If we can ingest vulnerability data like Rapid7, Nessus, or Qualys, we can then tell you if that exploit is being taken advantage of and by whom. Notice the attacker target from a name perspective. In addition, we're also looking at sensitive data flying through the environment. As I mentioned in the slide presentation, we look at 70 different kinds of sensitive data within the environment, and that is customizable. You can provide us some additional patterns and we'll add those to the environment. And if that is seen, we'll alert on that. And note, this is not a onesie twosie, which generates lots of false positives. This is in bulk. By default, out of box, we look for 50 or more. We can adjust that if you'd like to something higher or lower in that environment. And of course, if this traffic is encrypted and you've provided us with the certificate authority, we'll be able to decrypt that traffic and be able to see the same types of things as if it was clear text. So purely from an observational perspective, we can see the comings and goings of workloads. We can see if there's any vulnerabilities in the traffic. We can see if any vulnerabilities are exploited. We can learn the application traffic interactions, and we can see the sensitive data, and we can do that on encrypted traffic. And this is all without disturbing the traffic or adding any latency into the environment. But this leads us up to the enforcement side of the house. And that's all within access control. Now, I do want you to think of access control in more liberal terms, because even though there are rules and even though there are sources and destinations across particular services, it is quite possible that we will not implement full enforcement even if there's a violation outside of that. We can just observe the traffic violations and provide you with an alert. This helps our customers feel more comfortable with those particular policies before they decide to turn enforcement on. And you'll notice that it's a typical fall through type of rule base with a any deny at the bottom. And you'll notice that we have source and destination, and these are groups, but our groups are a little different. If you recall from the slide presentation, I mentioned that we can use attributes like naming conventions, tags, CIDR addresses, or the attributes associated with that particular groups. So in this case, you'll notice I have a web tier group. So let's take a look at the logic behind that. And what this allows us to do with this logic is it allows us to create a Boolean structure to match the tag to apply membership to a given resource group. That means as workloads are provisioned dynamically, if they have been provisioned under the rules within the organization, and we have created logic for these resource groups, as workloads are provisioned, we automatically detect them, we automatically add them to a particular resource group, and by inheritance, they automatically get security policies. This really smooths the administrative aspect of onboarding workloads in the environment. And this can be single clouds or cross clouds, as my example shows here. And again, for those on your cloud journey, if you have VM today and are moving to Azure or AWS or Google Cloud at some point in the future, as long as you keep some of the characteristics that match that logic to those workloads as they move, the policy will move with them and they will automatically be picked up. Really does smooth that cloud journey across the security realm as you move into the public cloud areas. So should an attack occur and it's been alerted on, we do provide full logging for that particular attack. We use a couple of tools. First is our Event Explorer, and we'll be able to see that attack in all of its details. So in this particular case, I executed a Samba attack on a host, and you can see it here. And of course, this can be syslogged off to a SIM or a SOAR environment. And for these types of attacks, natively, even without any other packet capture configuration, we will store the first 5 packets and the last 10 packets after that given attack. We also have a full Kibana interface that will provide us a lot of information in a more granular detail in that information that we provide out. We also have additional dashboards in there that we can look at, as well as statistical information that we have with respect to movement of data, latency within the environment itself. So it really does provide quite a bit of information from a textual or reporting perspective. And finally, when there is an attack, we will display from a graphic perspective back on the map how that attack occurred. So in this case, I have an initial affection that occurred back in April, an indicator of compromise, and I have all the details here. And then a lateral movement occurred a little less than a month later, and you can see that from a graphic perspective, how that interacted there. Let me slide that over a little bit, and I see all the details over here along with the associated events. And finally, I saw an additional lateral movement, which actually resulted in going external to the organization, and it moves sensitive data outside of it. So not only can we see the attack, but we can graphically represent the attack in the environment, so you can look at it, see all of those details, and use it to your advantage to ensure controls are put in place to prevent that kind of attack, if we're not already preventing it. Thank you for watching this short demonstration of the ShieldX Elastic Security Platform. If you want to know more, drop us a line at info@shieldx.com. And you can also visit us at www.shieldx.com.